Alrighty. Welcome to week 3. I didn't think I was going to make it today because we've had some storms here and my internet's been knocked out twice today, but we're going to persevere here in Orlando where rain is a thing. Okay, so let's start. Thank you for coming tonight, Leon and Emmanuel. Do you guys have any questions from week 2 or any questions about what we're seeing in week 3 before we begin?
I have a couple of questions.
Sure.
And I saw this originally, I think in week 2, but all the reading, and they keep talking about when they talk about join, they say inner join. And if I understand correctly, you don't need to say inner join because it's implied. Outer join is the only time you need to actually specify a join if you're doing something different.
That is correct. However, I will caveat that because we want our code to be clean and readable by everybody, we like to put inner there. You don't have to, but it's just a question of clean code.
So clean, when you say clean code, you're just saying that if somebody else were to come along and read it,
Yeah,
and they don't know that inner join, saying join is implied inner join.
yeah. And also keep in mind that is only in MySQL because in Oracle and Microsoft SQL Server, join is a Cartesian join. It's not an inner join.
So in other tools, you do need to specify.
Yeah, yeah.
Okay.
So it's a good habit to get into. When we start talking about insert, there's a number of things that are good habits in coding. And one is using the inner instead of the join, because for 2 reasons. One, when someone comes behind you and looks at your code, you don't want them to have to remember that join is inner join if you're using MySQL, or in Microsoft SQL Server, join is a Cartesian join as opposed to a true inner join. We're going to talk about this next week. That's a next week thing. We talk about the different kinds of joins. And but it's also about code readability. When we talk about insert statements, there's like 6 different ways to write insert statements, and one of them is very verbose. And I always recommend going the verbose way because it takes you a few minutes longer to write the code, but there's never any question about what that code does.
Okay.
And I'll show you. And the thing is, I'll show you some shortcuts and some cheats on how to write that code faster. Because it's not as hard as everyone makes it out to be. Because when you're using the GUI, there's some shortcuts in there that they'll write 90% of the code for you, and you just got to fill in the blanks. So like, let me just show you this here, sneak preview. Let me share my screen here. So if I go here to the actor table and I right click it and I go to where is it? Tend to SQL editor, and I say insert statement, it writes the insert statement for you. So all you've got to do is fill in the blanks there, right? So the GUI, and this is true in every GUI. If you're using Toad, if you're using SQL Management Studio, if you're using SQL Workbench, there are all these shortcuts built in that help you out in writing code faster. But yeah, we'll talk about joins next week. So you definitely want to do inner join when you're doing them, just for clarity's sake.
Okay, I understand. That makes sense.
Mm-hmm.
The next one is on slide 12 in the chapter 4 reading.
Okay.
They and in one of the videos they've mentioned it as well, where you have your, I don't know if you are familiar with it, but select title and rating from film, and then where rating in, and then select rating from film, where title like wildcard pet wildcard.
Yeah.
And they one of the things that they had mentioned is that if you can write it using a join versus this method, it would be cleaner and better. Is there a way to write this slide? This, because I wrote it out and I played around with it a little bit. Well, I didn't play around a lot. I just tried a few different things to see what it was doing separately with the select rating from film, where title equals pet, what that returned. Then the select title rating from film where title like pet, see what that returned. And I guess those are both the same, aren't they? Let me run this real quick.
Is this, do I have, do I have the, on the screen right now? Am I sharing? Yeah, sure. Is this what we're talking about?
Um,
It is also
let me-
about square, so where the generator is set for you. If you want to assume the title with the name pet would be safer family viewing, you can
yeah.
execute a subquery. Okay. And then once you write this with a join,
No, it doesn't say you want it. It in one of the videos, it
uh,
mentioned that if you can write it with the join, that it's cleaner. It's less taxing on the server. Where
well,
this is,
is it though? So let me think about that. So when you run it this way, right? So the SQL engine runs this part first and gets
yeah.
that results. So it pulls everything from title and puts it into memory and then gets that subset rating there, right? And does that. And then it does the second part. So it gets everything from film and does that part. If you do it with a join, it grabs both tables at the same time and pulls into memory. I don't
Well, so
personally, I don't think it's any easier on the engine to do it one way or the other because it's still pulling all the stuff there. Um,
well,
I think. Go ahead.
what I thought was interesting here is that you're pulling from film in both of them.
Right.
So,
Oh, that. Oh, yeah. You can write interjoin against the same table. We're going to do that. There, you can join the same table, and sometimes you have to.
okay.
Yeah. There are times. So if you wrote this as an inner join, let me take this here. Let me see. Just out of curiosity, because you brought it up, and let me copy this. Bring it over here. Okay. Okay. So I'm doing this as a join. So then I would do select F1 title, comma, F1 rating, from film, enter join, one, film, F2 on F1 dot film ID equals F2 at film ID. Where F2 dot title like
You got a double quote.
yeah, thanks. Okay, so let's see. No promises that this is correct or accurate because I'm doing this on the fly. And rule number one is don't code on the fly. So let's see. We got this, and this gives us 372 rows returned. And what does this do? We need 3 rows returned. So what did I do wrong here? Where? Oh, that's what it is. Oh, we're rating. Okay. We're rating in. Huh. I'll have to think about that one because that's weird to do that. We're rating in select. Oh well, you could do this. Oh. Oh, you could do this. Oh no, they want you to do it that way. Well, you could do it this way. Select star from. Oh, this more of this is fun. Yeah, there you go.
I've got a question. I'm a little bit
Uh,
confused as to the F1, F2
oh,
line
okay.
now.
Yeah, so we're jumping the gun here, and I got a little bit more. I got double, so I'm actually supposed to be 305, 6, so when you're doing an inner join, you want this F1 here is an alias,
Oh, okay.
okay? Because when you're writing a join and you're joining multiple tables, you have to let the command know what table this is coming from, particularly
Okay.
if the title column exists in multiple tables. So we got to
Mhm.
specify it out. I have to play this group, but this is roughly what you would do to make it happen. I don't think we don't have the. I need to find how to turn the execution plans on in here so you can see them. But I don't know that this is any less intensive than this is.
Well, the top one's cleaner because it's not going to return. I
Right,
don't believe it returns duplicates. Plus, you've done the same thing. I mean, you don't even need the inner
oh,
join.
right.
Oh yeah, I guess if you do distinct.
Yeah. Yeah, that's why I put those distinct in there. So yeah, so here's the same thing with an inner join, but here's the thing. I have a subquery here. I have a subquery here.
Yeah.
So I
And
mean,
if I understand correctly, do you actually need to call out in your select statement the F1? Do you need that
only
to be an alias? Only if it's in
so
multiple tables
correct. But again, it's
and
a
it's ambiguous.
right. So but also in the pursuit of writing clean code, if I've never seen this before and I've got a several tables and a multiple joins here, if I look at this, I will know where it comes from without I've looked at the tables. So if I had like a if I had like a ridiculous like 2,500 call a row piece of code that someone wrote for me, and I see the flex statement it said like F1 title, I go here and say okay F1 is film, so I know where it's coming from.
Yeah.
So you don't have to, but again, it's something that we it's good coding practice to do. So when someone looks at the code, they know exactly where it is without having to dig through it. But you're right. So if I was doing something, if I was doing an inner join that didn't um have matching columns, I wouldn't need to do that.
Yeah.
Yeah, I wouldn't. But it'd be more confusing for someone who's like just coming into the company or who's a temp or something coming and looking at the code. It's gonna take them longer to figure it out.
Yeah.
Aliasing is always something that it's just better. I mean, it's better than the other practice of like doing this. This is I hate doing this.
No, yeah.
That's just
That's
that's too much.
that's how they started out. I was like,
Yeah,
no, this is brutal.
yeah. And then the aliasing makes it easier.
Yeah.
And it like I said, and especially like down here when you got this going on, because when you're doing an inner join, the columns are probably the same name, so you do have to qualify which ones you're talking about. And the error you get will be like ambiguous column name or something like that.
Yeah.
Yeah. But yeah, so this is I mean this on the fly. This is how I write the query in inner join, but I don't think that it's any more or less efficient than this is.
Well, it
Not sure
makes
why.
sense what you say that it's putting the first select statement into temporary memory.
Yeah.
Then
Mhm.
the first then the next select is going to go and give you what you're looking for, or at least display what you're looking for. I could see how, but I don't know if that file is huge and it's returning more than thousands of
Mhm.
records. I don't know how you would clean it up to a point to make it
Exactly. And,
less.
and the same thing is happening here. Here, when I'm running, it's running this part first, right?
Yep,
Here, when it's
yep,
running, it's running this part first,
yep.
and then doing everything else around it. So, um, this is why your database servers would have like gigs and gigs, hundreds of gigs of RAM in it because all this stuff to go into it. Yeah. But yeah, so it's a question of making sure that this will all fit into RAM because if not, you do a whole bunch of swapping and it's crazy. But yeah, so that's kind of what they're talking about here. But again, like I said, I don't know. It's 61 half dozen the other to me. I don't know which one is better. Um,
I don't either.
yeah, I mean, this is a little bit more, I guess the word would be primitive.
Hmm.
The word would be primitive because this is like very simple, straightforward, and this is a little fancier because using inner joins, but I don't think it's a difference.
Well, to me the other one's easier to understand and read because
Oh, this one is, yeah, absolutely.
when you do you've got that join, you're joining the same tables, and
Mhm.
I don't quite understand why you'd ever do that. So
Yeah, and I'll show you some examples next week or week after next that that explain. There are times that where you actually have to do it. A lot of times it's when like if you got an employee table, right? And in the employee table, you have a column that says manager ID, right? And that manager ID links back to the employee ID in that same table. So if you're going to run them, so in the employee table, you know if they're a manager because there's a column that says is manager, right?
Mhm.
And then in there's a column that says manager ID. So if Bob is a manager and his ID is 6, and Bill, his manager is Bob, so his manager ID is gonna have 1, and it's going to link to the same table. Because we don't want to make a manager's table. We don't want to make a separate table for managers because that's redundant. We can't have Bill is Bob is an employee, but Bob is also a manager. So we don't want Bob's information in 2 different tables. So we just keep it in the one table.
Yeah.
But I'll show some more specific examples about that. There's
Later.
one on, yeah, like week 4 or 5 is when because next week we talk joins for the first time, and then after that we spend like 2 or 3 weeks on joins because we do inner joins, outer joins, except but all the things that go with joins. So that's about 3 weeks of conversations in there. But we'll talk about that because there's a question. I think in the week 5 exercise it talks about joining a table to itself, and it'll ask you to do that. But yeah, that's what that is.
All right.
All right.
Those are my questions.
All right. Emmanuel, you have any questions?
No,
All right.
not for now.
Okay. Cool. I like questions, and if you're watching this at home and it's Wednesday, it's Thursday afternoon or Friday afternoon, and you've got a question about stuff, go to the announcement, put a question in the comments, and then we'll answer it next week on the meeting. Or I'll answer. Sometimes there'll be a question in the comments that I'll just make a quick video and post that there because it's something that I don't necessarily want to wait till next week to talk about. Okay. So the stuff I want to talk about this week, we talked a lot about this. We talked a lot about this last week. We're gonna add a couple things to it. Because this is all talking about the where clause and how to use the where clause, inequality comparison operators, and things like that. So last week we talked about the where clause, and we had where length equal, stuff like that. So equal is a comparison operator, and if you remember your elementary school, we've got greater than, we've got less than, we've got greater than or equal to, or less than or equal to, we got equal, we have, and these 2 here are non-equal. So remember, the way I learned it back in elementary school, the alligator is eating the bigger number. So that's greater than, that's less than or equal to, that's greater than or equal to, that's equal. And now the kissing alligators means doesn't equal, right? But also exclamation point equals means not equal to. Now, in Microsoft SQL Server, I don't think in Oracle, this one is only used for string operations, not for numeric operations. This one will not work in numeric operation, or it will, but it'll be hinky. So this in Microsoft SQL Server, that is for numeric operations, that is for string operations. In MySQL, they can both be used for everything. So here, a couple just real simple. I've got select title length from film where length is greater than 100. That's self-explanatory. It's just gonna be greater than 100. Over here, I've got my and statement here. I can say select title and length and rental rate from film where length is greater than 100 and rental rate is less than 5. Keep in mind, we talked about this last week, and it's got his brother or. This means both statuses must be met. If I do or, that means either status must be met. So here, where length is greater than 100 or rental rate is less than 5, so I run this, and I get 1,000 rows returned because it's pretty much everything. If I do this, I only get 610 rows returned because there's only 610 rows that match both criteria. Okay. Last week, we also talked about using the wildcard operator here. We've got select title from film where title is like A, which means it's going to get me anything that starts with an A. If I do %A, it gives me anything that ends with an A. And if I do %A%, it gives me anything with an A in it, which is probably going to be everything because A is like the second most common letter used in the English language. Down here, I've got select title from film where title is like A underbar E %. So what this means is give me everything where title, the first letter is an A. I don't care what the second letter is. The third letter is an A. I don't care what the fourth letter is. The fifth letter is an E, and then anything after that will be fine. Thank you very much. I think this just brings out 2 results. Yeah, so. This one here, I'm not really sure why you would do this. I'm sure there's a reason somewhere. I've just never come across a reason to do this in the real world because you never something that specific.
Maybe when you're looking for a person's name,
Yeah, yeah,
a particular, no, different names are spelled differently. So
yeah. Like do character stuff. Yeah, and I get that, but it's like when I think of these queries, I think how's the front end going to translate this into the back end? Because this is a static query,
yeah,
so like this. So how do we make this dynamic? You know. So I know a lot of places like when you do searches, you can like do like D, you know, R, Y, whatever, right? You know, for your wildcard or maybe the way to convert, maybe that's the way to translate over, but this is just the mechanics. This is how we do things, not necessarily why we would do them.
okay.
So here we have the like statement, and we can put not in front of anything. So select title from film where title's not like the. So anything that doesn't start with the. And if I take away the not, it's anything that starts with the. And then I've got select title, length, film rental rate from film where length doesn't equal 100. So it gives me everything that doesn't equal 100. And then we've got comparison operators, which we talked about before. It's the between 50 and 100. You can do that for dates, numbers, anything numeric, anything value based. You can throw the between there. And as we saw before when we were playing around over here, you can take select statements and put them into subqueries. Now, this is referred to as a nested subquery. There is a limit to how many subqueries you can nest. I think it's very few in MySQL. I think in SQL Server for Microsoft it's like 15, and Oracle somewhere on that too. So you can have 15 nested subqueries. It just gets a little ridiculous if you start doing that, right? The last lesson of is it the last or next to last lesson in this class is on views, and that's what you want to play with as opposed to nested subqueries. A view is a query that's been made permanent in the database. But we're jumping ahead 12 weeks here, so we'll dial that back in a minute, right? So we can put the subqueries into the length statement. As you saw over here, we can put the subquery in the where clause. We can put the subquery in the join. So we can put subqueries anywhere. You can even put subqueries in the select statement. And I think somewhere along the line, there's an example that I'm not sure if there is, but if not, I can knock one out. But yeah, there isn't a place anywhere that you can't put a subquery. Okay. And that covers everything I needed to talk to tonight about the code that you're going to experience in week 3. Do you have any questions?
I do have a question.
Sure, hit
Go
me.
back to the slide 12 one, the select title.
Yep.
If you run that command, what I don't quite understand is that the select from film where title like wildcard pet wildcard, and unless I'm blind, I don't see any of these titles having PET anywhere in them.
So in here, okay, so let me have that query over here.
I think on
So
a
yeah,
database.
if you run it,
So we're talking about this one here, right?
yeah, run that one.
Okay, so let me do this. Let me bring it down. Let me run it by itself, and let me add title into that.
Where space. Space doesn't matter. Okay.
No. So here we got select title rating. So my subquery is pulling up these 3. So there's Malkovich Pet, Muppet, Pop Mile, and then Pet Haunting.
Yeah. So there, but if you run it up in the if you run that one, why does it return values that don't have PET?
Oh, because so what's happening here is this when I'm running this, it's getting here's the rating, right? So it's getting PG and P pulled out. So what this actually means, if I were writing this in a way that wasn't confusing, this query and this query are the same thing.
So if you run this, then
it gives me the same. It'll give me the same results as
that top one.
Mm-hmm. Now, the reason why we do it this way over this way, okay? This is a static query. This will never change. Okay? So this will always return G and PG. This will return. So right now, when I run this, right? I get these 3, right? So let's say update. Let me see something here. Update rating. Update film. Set rating equal to R, where title equals, okay, run that. Okay, so now when I run this, I get 3 ratings now, right? So let's say, and let's say instead of, let's say we add a new film called Pet Haunting, and it's rated R, right? So when I run this query now, the results change. When I had it static set, that's never going to change. We use subqueries for dynamic queries that will change based on the changes in the table. So I mean, this is a very simplistic way of looking at it, but like, let's do the,
let me see if I can repeat and see if I'm way off or close to the mark. Because all of this content is back end, but your front end is going to control whatever somebody says. So if I want to do a search and I want to look for stuff that says, hey, I want things that have pet in it.
right.
If you wrote it like you did on line 10, you wouldn't necessarily be able to make it, wouldn't be dynamic. Whereas in line 4 code from the front end could put whatever they want to put inside
Right.
those percentages.
Right. Because this query here has nothing to do with pet. It wants to see what ratings match, right?
Yeah.
This is just giving it a basis to get ratings to compare it to. Right.
Yeah.
So and in the coming weeks, I have a bunch of queries that kind of play with this concept and changing out to make it to use subqueries for things. So we'll talk about that more. But subqueries just allow for dynamic querying as opposed to static querying, which is important because your database, your table should never change. I'm sorry, your data will always change, so you never want to query that's querying the same thing over and over again without taking into account that could change.
Yeah.
Yeah, and that's what it comes down to.
Okay.
There are better ways to do it, but that subquerying is the one way to guarantee that it will always be data driven as opposed to static.
And static can be a problem.
Well, static is always a problem because it's not I mean, let's say, if we're looking for if the query rating is like show me movies that are good for kids, then that's going to be the query, right?
Yeah.
But if
Yeah.
it's like here, so like we have a genre here, but like if I want to like show me films and ratings where it changes around, like if I wanted to find like what horror movies were good for kids, I could write the query in such a way where I have a subquery that pulls out ratings that are PG, PG-13 and compares to all the horror stories, right?
Mhm.
So it's a great question, and obviously and honestly this doesn't come up until week 5 or 6. I'm glad you bring it up now. But yeah, this is about dynamic queries, and we're gonna be talking about a lot of those as the semester goes on.
Okay.
Yeah. All right, Manuel, got any questions?
Okay.
All right.
Understood.
Okay, so then let me switch gears here now, and let me talk about the final project. Because if you follow what is on this page, you're going to overdo everything and not do the project the way I want you to do it.
All
So
right.
like I said, this course is this syllabus is taught by 8 other instructors, and we can manage things the way we want to manage them. So I make a couple changes in this, okay? So when you're looking for, and this is the important thing, this is due on week 13,
Oh,
but the
okay.
discussion of this is in week 3. So when you're looking for this, you got to look in week 3 to find it. So when you go into your modules, there's final options. Okay. And then you click it to here. So here's what I expect in the final project. And here's what it is. In the final project, this is a complete design option for you guys to do. You'll be designing a database to work a back end, to be the back end to an application that you are conceiving. So think of a need. Think of something that, if you'd say, if I had an application to do this, that would make my life so much easier. In the past, I've had students do an inventory system for food storage. I've had people doing inventory systems for their record collection. I've had people doing scheduling databases for their kids, scheduling databases for the schools they were looking for. I had one guy who worked in some kind of chemical lab, create a database to keep track of chemical compounds and their results when you mix them together. It's whatever interests you that makes it more exciting. So something that you see as a need that interests you, because ultimately, if you're of the mind, I've had students in 7 years of doing this finish this off, make an app, and send it out there because you can have a MySQL backend, because this stuff is free, right? So here's what I want from you in this exam, and I'm going to open up my whiteboard function here. If I can remember where it is. Nope. Where's my whiteboard function? Oh, you know what? I need to do this, and then I need to do Nope. Where is apps? No. Where's my? Nope. Hang on a second. Did AI? Oh, there's my whiteboard right there. Okay. So go back to sharing again. Go away. That's fine. Go away. Okay. Go away. And back to screen share. Oh wait, where they were. Okay, so here's exactly what I want from this project from you guys. First thing is I want an ERD. ERD stands for Entity Relationship Diagram. That is the picture, and most of you did this in your week 2 assignment of reverse engineering database. I want the graphical representation of your database. I want you to go into MySQL, I want you to go into here. I want you to create a new model. And I want you to draw it in here and then send me a screenshot of it. Don't send it to me any other way. Okay. Actually,
You're talking about the tables, right? You're showing.
Yep.
Because you're not talking about you. Go ahead. Yeah, we can't see your.
Oh, you can. Oh, that's hang on a second. Let me fix that. Because I'm only sharing my. Let me see. Share the screen. Okay. Here we go. Okay. Here we go back to here. This one here. Don't save. Okay. So that's not the one I wanted. I gotta rid of that.
That's what you're asking for is an image of
Yeah.
this.
Yeah, I just I want to show you a nicer one. Let's see the runner one. Is that the one? Open.
Not Pokemon.
That's the one I use for the Pokemon one is what I use for tables joining to themselves. So here this isn't great, but here this is the ERD. I want you to send me a picture. I want you to take me a screenshot and send this to me. Okay. And I bring this up here because the second thing, let me do this in MS Paint. Let me get fancy and go MS Paint here because that'll be easier. So here we go. Let's confuse the screen here. So I'm gonna go here to paint. So the first thing I want is an ERD. Okay. I want you to send me this thing.
Okay.
The next thing I need is the code to create the database.
So reverse engineer it.
Yep. So you go here, you go into the commands here, and you go here to tools, open to database, reverse engineer. And actually, it's forward engineering in this. So here I go to database, I go to forward engineer, and I click next. And I don't want to skip anything. Click next, export all my tables. There we go. Boom. And there's the code to create your database. Copy to the clipboard and send this to me. Do not send me the MWB files. Do not send that to me because I can't open it. Because your MySQL, your MySQL on your computer, my MySQL are two different versions, and it will not be able to open yours.
Okay.
So all I want from you is the code to create the database. Okay. Next thing I need from you is I need the code to insert data into the database. Okay. So you are going to generate code for me to input data into the database. Now you ask, why would you do that? Because the next thing I need from you is code. So let me do this here. ERD with 6 to 10 tables. Okay. I have found when designing databases, and this is just me, if I hit 6 or 7 tables and I stop, I'm good. But I go from 7 to 20 very, very fast. Because, and we'll design some databases starting next week after, where you'll see where all of a sudden we were at one table and then some were at 10, and we can still see branches to go off on to create new tables. Okay. So I don't want you guys to create an entire like 30 table database. I just need you to create 6 to 10 tables that perform a function of the application that you're imagining. Okay. Then I need you to create code to insert data into those tables because I need 5 to 7 test cases and the code for them. So what I mean by test cases is how do you foresee people using this data? Okay. For example, the one of my students who did the food storage database, they did it they got super complicated, but this wasn't their first rodeo, so it was okay. So they basically designed a database that had 2 sides to it. It had what was in your food storage, and then it had a series of recipes within there, right? So then the students started writing queries. Do I have the ingredients for this recipe? And so the query would go and visually say whether or not what was missing for that recipe. I've had students who so like this so like that for like so if you did a food storage database, but a simple one, just that was the inventory of food storage, you can say you can write it, say I need to know what in my food storage is over 3 years old. I need to know what my food storage has less than 5 in inventory. I want to write a query for my food storage so I can tell what I've been using more of, right? As I'm cycling it out. I want a query that's going to show me what foods I have to use now before I have to get rid of them. So it's kind of like, we're supposed to rotate the food inventory. So these are all things that you'd use the data for. So I need 5 to 7 of those. Now, what I strongly suggest is you do it in this order. Do that first. Do that second. Do this third. Okay. Write the test cases before you put the data in. And the reason I say to do this is because when I grade this project, the first thing I'm going to do is I'm going to take this code and I'm going to create the database on my machine. And because you guys are great, it's going to go without errors. And I'm going to go, great. And then I'm going to insert the data into the database. This will be 4th. And then I'm going to run your test cases. The test cases, when I run them, have to have results. Because if they don't, I won't know if they worked or not. It'll say 0 results, but that's that because there was no data in there, or is because your logic was wrong, right? So when you write the 5 to 7 test cases and then say, okay, if I did, I'm doing food storage, this query shows me what storage I have that expires within the next 3 months. I need to make sure that in my food storage data, there's stuff that expires in the next 3 months. I want to know, what item has less than 3 on hand. I need to make sure there's at least 1 item that has less than 3 on hand. Are you following me?
Yeah.
Okay. And this is all stuff that we can talk over together, because once you get your idea, and once you have the idea and start building the tables out, once we talk about and I give you like 1 or 2 ideas on how to write what test cases to do, it becomes easier. It's like all of a sudden they start flowing out. Like, how would I use this data? How would I use this data? Right. The 5th thing I need is a simple mock-up of the front end. And how it connects to the back end. Okay. So when I say simple mock-up, you can draw it in crayon on construction paper for all I care. Okay. But all I need to see is I need you to show me, here's what I think the front end would look like, and here's how this box here will point to this table, this button here will point to this query, this box here will point at whatever Howard's. So I just need to know how the front end matches up to the back end. And I will show you examples of that. Because again, you've got 2 weeks to do this. So over the next 10 weeks, I'll be showing you examples of each of these. And the last thing I need from you is a video or PowerPoint presentation on the project. And that's it. And the video PowerPoint presentation is just like, here was my idea. Here's how I designed the database and why. Here's the test cases I had, and here's how I populated the data for them, and here's the mock-up. It's like 3 to 4 minutes long on the video, the PowerPoint. That's fine. And then you zip all this up and you send it to me, and that's the project.
This is due on the 13th.
Week
The 13th. Week
This
13.
this is due at the latest week 13.
And from now and so for the next 10 weeks, we could technically write our idea up,
Yep.
and then communicate with you on collaborate with you. Let's say not communicate, collaborate with you on ways to achieve
the goal.
Absolutely.
the test code, because that's, I think the test cases, I can picture what I'm picturing right now, but I think I'll be honest with you. I had a programming class, and the teacher said, "Hey, you can all either follow along and do the stuff, or you can write a unbeatable tic-tac-toe game. Whichever you do, just we'll get you your grade." And I chose the unbeatable tic-tac-toe game, and I still have hair, luckily, but it was brutal. So I've been, as I read the thing, read what was required, I was like, wow, I don't know, but I mean, yours is not much different. But
when you read this stuff,
when I read this, I was like,
this is terrifying.
Yeah.
That's why they don't let me change this. If I could, I'd absolutely change this. Minimum of 12 tables. The CRUD statements. No one needs that. And the index and maps. Yeah, this is too much stuff. So I just leave it to this.
Okay.
And it's interesting that you say collaborate. So here's how you collaborate with me. If you decide to do this starting this week, your weekly essays are going to be a journal entry to me on how you're doing. So like this week, hey, I was thinking about this. I'm being toyed. I'm between like doing a database to collect to manage my record album collection, or a database to manage like a gardening store that I want to open, and then we'll kind of talk, and I'll respond. And the response I'll give to you will be, hey, I think this is kind of cool, and this is gonna be kind of fun. And then you could, like, during the course of the 10 weeks in those things, like, I'm stuck here, I need this here. Look at here's my ERD. What do you think? And these Wednesday night meetings are also for that. Tuesday meetings are for that. Like at the end, if there's any questions, you can bring up your ERD. We can discuss it as a group and do. And this, I really try to make this class as much as collaborative as possible, not just between me and you guys, but between all you guys, right? Because in the real world, if you're working on a project in your office, you're not doing this in a silo. You're working with 5 or 6 other people, right?
Yeah.
If you're a programmer, database operator in a company, you're not writing code on your own. Matter of fact, there's a whole process. The team I work with during the day, they'd never used peer review before, so I instituted a whole process of peer review. Because I know you think you're great, but everyone makes mistakes, right? Yeah. So this is as collaborative as you want it to be. There are people who are not watching these videos, not coming to these things, who are going to do this. They're going to see this and they're just going to do this. And I'm going to feel very sad for them, because this is a very painstaking thing that they're putting themselves through, and they don't have to. Because all I want is this. Okay. So this, and again, keeping in mind that you guys have barely started to write code. So by about week 5 or 6, you're going to start getting really comfortable with writing code. Because the thing about T-SQL code, it's very, what's the word I'm looking for? It's got a pattern. It's very patterned. And once you understand the pattern, writing the code is easy. You will still get plagued by missing parentheses or quotes in the wrong place, or there's a comma missing, and those errors that plague everyone else. But for the most part, once you understand the tempo, pattern, however you want to put it, of the code, writing it's no problem. And with the test cases, again, really, once you think about the database that you want to create, and then you want to think about, hey, people use it, you'll run into way more than 7 test cases that you'll come up with. Because once you get your brain thinking this way, it becomes very easy to think how people would use the data. Right? Because that's our job as database engineers, administrators, whatever. Our job is to take the data that is housed in our database and put it in the most presentable form so anyone can understand it. Because since we're in a relational model database where we've got 30, 40, 50 tables that all house the information that one person wants in a query, we need to find a way to give it to them when they ask for it and not have to go to 30 different tables to find it. Right? They don't need to see what's under the kimono. They just need to get the answer that they want. So and when we made when I put in my suggestions for this final project, they got creative on what they did over here, and that's cool. But because they give me the freedom to do, make it customized to what I want, I have yet to run into someone who looks at this and goes, what they have here, and go, yeah, I could do that. I'm not even sure I could do that. I've been doing this 20 some odd years.
Well, I'll admit, when I read it, I was like, no.
Yeah. So this will be it. This is all you need. You'll know. I'll put this in the meeting notes. That's what you need for the final project. But yeah, it's a lot easier than that. Because the point of this class for me is to have you guys leaving here feeling like you've learned enough to go and work a database. And working a database is not as complicated as a lot of people would want you to believe it is. It's complicated, but it's not like, rip your hair out complicated. So, but that's what the final project is. It's these 6 things and 10 weeks of essays telling me how you're doing.
Essays and asking questions.
Yep. It's not even, at that point, it's not even an essay. It's like, I'm doing this. It's communication. It's basically a chat room for you and me to talk about this stuff.
Yeah.
I don't know how OneDrive got enabled on this computer. I got to fix that.
But
yeah. OneDrive. Yeah, I think it just patched itself the other day. Now all of a sudden OneDrive is everywhere, and OneDrive is almost like malware, I think. It's not supposed to be, but it is. But anyway, so yeah, so it's just these 6 things.
Cool.
And it's it. And like I said, the essays, or like on Wednesday nights, any questions? Yeah, hey, I'm having a problem with this ERD. Can you look at it? And the biggest problem people face in this, it's normalizing the database the right way. It's always in the ERD that people will have the most difficulty. And that's why I encourage you share your ERD to me as often as you can and pull it up in class as often as you can. Because that's how you get it hammered out.
Okay.
Any other questions?
No questions.
All right,
comment.
Huh? Go ahead.
A comment. I don't know if you guys have ever heard of rubber ducky debugging.
What's that?
Oh, look it up one time. Rubber ducky debugging. It was, I learned it in one of my classes where when you're having a problem, this guy was basically a programmer, was trying to figure out a problem, and he couldn't for the life of him figure out he couldn't get the answers to the questions. So basically I don't have a rubber duck, but I have Groot. He basically spoke to rubber duck, and by speaking it out loud, it helped him recognize, hey, this is what I really needed to do. And it's actually worked for me. I had my wife sitting here once till 1, 2 in the morning trying to figure out some coding, and she did nothing because she doesn't understand it at all. But just in bouncing the conversation off of her, I was able to resolve my thing. So basically, that's what you're going to be the rubber duck.
I
Okay.
I agree with that. I have testimony of that because I have talked to my wife. I've talked to my Weird Al Yankovic head that I keep right here. Um, my dog, my reflection in the mirror. If there's something that when you talk things out loud, you'll hear because when you're sitting there looking at it doesn't get anywhere. But when you start talking it out loud and trying to explain to someone, you'll go, "Oh, that's what." I don't know how many times I've gone to one of my peers at work and I would say, "Hey, look at this code. I'm doing this. Oh, never mind." Or like in the time I'm waiting for them to respond back to me, I find the answer because I'm trying to explain to myself to what it's doing to them. So yeah.
Yeah.
The only thing I still have a problem with in coding is, and it'll actually force me to rewrite the entire query, is if I get the missing a parentheses error. Because if you're writing a super complicated query with like 50 or 60 different parentheses sets and one of them is missing, you just give up at that point in time and start over. I know it took me an hour to write this query, but I'm done.
Yeah, it's
Yeah,
frustrating.
the parenthesing is, yeah.
Today I wrote I wrote probably I wrote the same query,
Mhm.
but I had to write it for multiple different markets.
Right.
My brain was just I was in that loop, and it was
Yeah.
just going and going, and then I started testing against my data, and my data wasn't bringing back anything, and I was like, this doesn't make any sense. So I reached out to a coworker and I said, I need a second set of eyes. And as soon as she popped in, she goes, "Oh, is the master contact being updated properly?"
Yeah.
And I'm like, crap, that was it. So I had
Yeah.
to go and fix the master contact. Once I got that fixed, all my data showed up, and I'm like, that was so frustrating.
Yep.
Hours.
Yep.
I spent 8 hours writing code. It was brutal.
Yep.
And it was the same code over and over and over again, but doing it all day long. It was brutal.
Yep. And that's why 2 years ago I made the jump to management, so I don't do that anymore.
Well, unfortunately, I'm a manager. I do manage a guy at work, but
Yeah. No,
they just
I
they,
got
they just put it on me. They said, "Hey, can you manage him?" And I'm like,
yeah.
"Oh,
Oh,
okay."
yeah, I got two teams. I got 7 Oracle DBAs and 3 SQL DBAs underneath
Oh,
me.
you got a
So
big group of people.
yeah. So it's interesting. It's interesting. But yeah, so that's why I say, like I said, this class is as collaborative as you want it to be. There are some people, out of the 20 people in class, there are people who are going to like put their head down, just do the stuff and try to do the final project and get super. They're going to come to me on week 12 and ask me what they're doing wrong. And I'll go, well, did you go back and look at my assignment? Did you go back and look at the video? Did you go back and look at this? So, this is his class. If you haven't noticed, I mean, all the tests are open book, all the quizzes are open book, all the exercises are open book. The answers are on the back of the book. This class is low key made to encourage you guys to talk to each other for help.
Yeah.
And it's just funny. I mean, really, because you two are watching this, you could theoretically get a video call with 5 or 6 other people and to do the exam together, the final exam together. Because there's nothing against that. And
Yeah.
matter of fact, I think in some cases it's kind of encouraged because it's one of those things like when you're working with other people and you're explaining things to them and talking to them and kind of teaching them along the way, you end up learning more along the way while you're doing it, right?
Yeah.
Yeah, that's good.
So yeah. So I mean, I mean, obviously there's proof that I said that. I didn't suggest it. I said, but you could probably do it and get away with it. But and yeah, keep in mind, it's the first that is it's the final project or the final exam. You don't have to do both.
Okay.
Yeah, you don't have to do both. I mean, I've had people do both because they thought it was done, and then I gave them the better of the 2 scores, which is almost always going to be the project. Um, but yeah, it's just one or the other. Just do one or the other.
Well, I think I'm going to try the project. I have an idea, so I will write it
Cool.
up, and we'll
Yeah,
collaborate, talk about it.
I'll tell you. So the story I tell about this is I remember years and years ago, I was sitting at a Chili's with some friends, and I was waiting for the waitress to show up to pay the bill. And I'm like, guys, we've got tablets now. And this is when tablets were just starting to come out and be real things. I said, we just need like have a tablet at this table where we can just pay our bills ourselves and not need the waitress come back over. Lo and behold, 10 years later, there they were. I didn't do them. Someone stole my idea, but that's cool.
Yeah, it is a cool idea.
Yeah, and I was in Olive Garden last night. For $2.99, you could buy 1,000 games and pay your bill and order there, not have to any human interaction.
Yeah.
But
I prefer the human action, but
I do too. I do. I do.
but it does
All
make
right.
it easier.
It does.
Thanks,
I mean,
Chris.
I don't mind so much. I don't mind so much paying my bill that way, but I'd rather not like order my food that way. You
Yeah.
know.
Nah.
So, all right, gentlemen. If there is nothing else, we're at time.
Oh.
So great. Thanks for coming by, and we'll meet again next week.
All right. Bye-bye.
Bye, guys.
All right.